Plan to throw the first one away is something that Fred Brooks said in the Mythical ManMonth, which describes his experiences working on very, very, very large and complex computer engineering projects involving lots and lots of people. So, I totally just yanked that out, good Lord. Oh, it's okay, yes, okay, it is still working, good. Okay, so Alan Kay made the observation that between the ends of the spectrum that have opinion on one end and action on the other, science meets in the middle somewhere. And I'm honestly not sure how much science there's really going to be in this talk. There will definitely be a lot of opinion. There will also be a lot of deeds, and we'll just have to see how much science we can get out of it. But a little public service announcement before I go on. So, imposter syndrome is a topic that has come up more and more in the last few years, often because somebody is complaining that they are being made to feel like an imposter by somebody else. Well, that may be the case for some people, but the struggle is real, even if it's you making yourself feel like you're inadequate. This is basically the job that I'm in right now is the first time I've ever had to manage anybody, much less a team of 9. I mean, when I started this job, I went to my friend who started the company, the CEO. And I said, look, this is a really cool project. I want to work on it. I'll do architecture, I'll write code, whatever you want me to do. And so in early January, he just casually says, how do you feel about being CTO? And I'm like, well. But the thing is, like Winston Zeddemore advised in the original Ghostbusters, when somebody asks if you're a god, you say yes. So I said yes. And it has kind of been, a half year of constantly second-guessing myself. This has been the most difficult talk I have ever had to write, just because I was constantly revising up until the very, very, very last minute. I mean, so what does imposter syndrome feel like from the inside? Well, to me at least, it feels like a giant case of the Dunning-Kruger effect. Either it's the case that, I think I know what I'm doing, but I'm really just screwing up terribly and I'll find out later when it all comes crashing down horribly, or I'm making things hard on myself by second-guessing myself too much, and I don't know which it is. So, after struggling with this for far longer than I needed to, I finally just went and talked to Fari. And Fari told me, look, the fact that you are admitting that you don't know anything puts you way ahead of most managers that are already out there working. So I felt a lot better. Thank you for that, Fari. But, I'm still probably going to stutter a lot, and I apologize for that. So, let's talk about the Mythical ManMonth itself, starting with its author. I mean, he just looks like a really happy guy. Like, I'd like to know this dude. He was the guy who managed the entire development of the IBM System 360 family. So, like, this was way back in the day. Waterfall methodology was the order of business. We didn't even have a lot of the terminology that we use these days. Every time you use the phrase computer architecture, you are using a phrase that he coined. Every time you use lowercase letters, you are using something that he brought into being. System 360 was the first architecture to have 8-bit bytes. It was 6-bit bytes before. You can only fit, you can only fit uppercase characters into that. This gave us lowercase characters. I mean, he's been awarded, all kinds of different fellowships and important computer science awards, like way too many to list on just one slide. I mean, this guy has a pedigree. And what he is most famous for is the phrase, adding manpower to a late software project makes it later. Who's been on a death march here? How many of those death marches had more and more and more and more people getting added to them as time went on? Yeah. I mean, it's typical. Like, this advice dates back decades, and yet people still violate it all the time. But it's not just that one line. He goes on to say, immediately after that statement, that the number of months that it will take to do a project depends on the sequential dependencies. What tasks have to be completed in order for other tasks to get done. If you can work out what you need to do and figure out, okay, X needs to be finished before Y, which needs to be finished before Z, you can figure out a rough estimate of how long it's going to take to do that, but it's necessarily going to be bounded by how many things have these, these linear dependencies, can't be parallelized. Furthermore, when you're assigning people to those tasks, the number of people that you can meaningfully assign to projects is going to depend on how many subtasks you can break the tasks that that you're working on down into and work on those in parallel. Now, this is really reminiscent of another observation by a guy named Melvin Conway, who pointed out that organizations which design systems tend to produce, well, I mean, he actually said constrained to. I mean, in my experience, it's really been more like tend to, but even so, like, you see this more often than not. However, groups communicate with each other, that tends to also be how the components of the system communicate with each other too. Another phrasing of this is, if you have 4 teams working on a compiler, you will get a 4-pass compiler. So this is useful advice for figuring out how to allocate your people. But an important reminder is that if you try to crunch the schedule by adding more people, you're only going to frustrate yourself and make it later. He's also got some very good advice on how to schedule things. And we'll see this being used later. He advises that fully 1/3 of the time that you have available, and more if possible, go into planning. Coding, surprisingly enough, is only 1/6 of the suggested time in his scheduling heuristic. The idea being that if you do your planning right, if you design your system modularly, if you specify your interfaces well, if you figure out the semantics of what you're going to be doing cleanly, then coding it is really more a matter of just writing that down. And then half the time available is allocated to testing. And the reason he says this is, as I've certainly experienced, and I won't be surprised if other people have also run into this as well. As coding tends to slip longer and longer, you end up eating up time out of testing, and you really don't want to do that. But it's going to end up happening anyway. So you might as well at least plan to have your tests ready to start using at the absolute latest halfway through this development cycle, so that you can find where you screwed up, so that you can start finding where you screwed up when you were coding, because you still have to debug things. I mean, this is the test phase isn't just about writing tests. It's mostly about debugging things that your tests show you that you got wrong. Another really important observation that Brooks came up with has become known as the second system effect. So you write your first system, and as you're writing, it occurs to you, oh, I could do this cool thing, I could do that cool thing, I could add this other feature, but you don't have time to do it right now. So you set those aside, and then you end up pulling them out, when you end up developing the second version of the system. And thus, the second version of the system tends to be vastly more complicated than the first one. And this is a problem because it leads to maintenance nightmares. There's another effect called the third system effect that supposedly produces a happy medium between the spareness but bad code of the first system and the over baroqueness of the second system. But development schedules, being what they are, sometimes you don't even get a chance to do the third system. So it's better to try to get the second system right. And he's also, Brooks also popularized several other observations that we just kind of take as part of the jargon these days, like the notion of a 10x contributor. He refers to actual empirical studies that were done on people's coding abilities, and these were the programmers that they worked with were people who had been programming for a while, and there was a massive variation in ability between them. Another thing that he points out is that the maximum useful size of a team seems to be about 10 people. And this is one that I've noticed empirically being true, pretty much every place I've worked. My husband's former boss, for instance, just refused to allow his team to grow above 10 people. And when they had something else they wanted to do that would have required adding more people, they started an entire another company to do that project. But this is really to me his most important planning contribution. He points out that it's not whether to build a prototype and throw the prototype away. That's gonna happen whether you intend to or not. The question is simply, are you gonna ship the prototype, or are you gonna pitch it and build something that's actually robust and reliable and worthy of shipping? So let me give you some background on what it is that we're actually doing so that the rest of the details of this talk will actually make some sense. So the company I work for is called Mautanoa Technologies. Mautanoa is Samoan for promise or guarantee. And we're basically doing humanitarian finance. You could also think of us as disaster PayPal. How did this get started? Well, so back in 2014, our founder, Emerson Tan, was doing some volunteer work for Doctors Without Borders. He was building out a patient contact tracing system so that when somebody checked into a clinic, they could find out, okay, who does this person know? Do we need to let these people, so that we can get in touch with these people and let them know, hey, you may have been exposed to a deadly hemorrhagic fever. However, this project got interrupted because there was a slightly bigger problem. The Central Bank of Sierra Leone realized that they were about 6 weeks away from running out of cash, completely out of banknotes. And the thing is, Sierra Leone is very much a cash economy. All of the healthcare workers in the entire country were paid in cash. This is a real problem if your country is on the brink of succumbing to Ebola, and you can't pay your healthcare workers. Because if they don't get paid, they're going to go off someplace and find some other way to make money. People are going to wander out of the hospital. Disease is going to spread. Rocks fall. Everyone dies. And 6 weeks is not a lot of time. There was actually some serious discussion for about an hour there of just straight up dollarizing the entire Sierra Leonean economy. Because you can fly C-130s full of dollars in. That does work. That said, it tends to have extremely negative externalities on the rest of the economy for basically the rest of time, so they decided not to go that route. So a couple of large enterprise companies that I will not name and shame, at least not while being recorded. They were like, "Oh, we totally got this. 6 weeks, that's plenty of time. We'll implement something in-house, and we'll see you in 6 weeks." And Emerson was like, "No, not only no, but hell no. It will explode on contact when it actually gets deployed, because people in Silicon Valley and people in Germany have no idea, what doing business in a country where illiteracy is really widespread, for instance, is like." Well, what ended up happening was Emerson was introduced to a guy named Sultan Masali, who lives in Freetown and runs a company called IDT Labs. We're actually working with these guys right now because they're great. They had already, as it turned out, built out a payroll system for one of the local cell phone companies that paid people in cell phone minutes. Now, this was an unofficial currency at the time. In many other African countries already, cell phone minutes were already being used, like in Kenya with the M-Pesa system, just as a parallel currency. It was unofficial here, but they were successfully paying about 2,000 people who worked for this cell phone company. So they look at that, he looks at that, and they're like, and he's like, okay, well, do you think you can scale this from the 2,000 people that it's currently serving to, like 30,000 healthcare workers? And they're like, well, we better. And now this was an SMS-based system because they were able to count on healthcare workers in cities having cell phone access. In other high-stakes scenarios, we can't necessarily count on having a reliable network. So that ended up going into our design criteria, because what Emerson realized was that the disaster management cycle is an ongoing process. When something catastrophic happens, there are 4 phases that occur in response. The first phase is the actual emergency response phase. This is where people are getting rescued out of burning buildings and dug out of collapsed structures and things like that. The part where we come in is the recovery phase and the mitigation phase. Basically, we're going to be working with NGOs like the Red Cross, the United Nations Development Project, and so on and so forth, to support cash as aid programs that they want to deploy. So that gets rolled out after the immediate emergency response is taken care of. So we ended up recruiting a bunch of people. So this is my team. Well, this is most of my team. This is my team minus our DevOps person who was in Turkey at the time. And I got to say, it is a great bunch of people. I mean, these are some of these are some of the most talented people I've ever had the pleasure of working with. It is also the most spectacularly neurodiverse team I've ever run into. Like, just about everybody on the team is on the autism spectrum somewhere. OCD is prevalent. I mean, like, it's interesting to say the least. But when you're talking about 10x performers, I lucked out. Emerson likes to describe his team as a stable full of thoroughbreds and Alfa Romeos. Like, they love to be out on the track performing, and they will run so hard that they will burn themselves out if you don't take care of them. So a lot of what I find myself doing these days is basically just helping other people to keep their focus. And what are we focusing on? Well, there's a bunch of moving parts to this system. First and foremost, we need a digital cash protocol that works offline, which I ended up designing. This is going to be a mobile app. We're just doing Android. We're not going to bother with iPhones. It's not a simple app either. I mean, there's also like a service attached to it and so on and so forth. We need a backend so that we can keep track of, so that we can keep like an overview, essentially, of the state of the economy that we are essentially maintaining. We need ways to look at that. And also, for extra complicated fun, so it turns out that there's not really any great way to manage secure credentials on Android. Like, most of the mobile payment systems that are out there right now are using white box crypto, which I don't trust for a variety of reasons. However, the secure element feature that sort of notionally exists in Android and is sometimes implemented in hardware is basically like unusable, because none of the manufacturers will let you actually like sign any Java cardlets to go in them. So instead, we're just using an actual hardware token. We're going to be handing out NFC Java cards that people will be using as signing tokens, and I'll talk about that a little bit more later too. And finally, tying it all together, our QA process involves, not just your standard, unit testing and integration testing, but we're also doing large-scale simulation. Because when you're dealing with potentially millions of people using a system, You want to know if the code's going to break at scale. But there are other assumptions that you want to be able to examine as well. And we'll talk about those some too. And one question that I keep getting over and over and over again everywhere I go is, so are you doing this with blockchains? No, we are not. Blockchain is not even a possibility for this use case, which is something I have to keep reminding people, because blockchains require you to be online. You have to have a reliable network connection in order to be participating in the gossip part of the protocol. And if you can't do that, then transactions are just not going to resolve in a reasonable amount of time. We had to optimize for very, very, very narrow pipes that are not always available. So we did something different instead. So let's talk about another company that has practiced the throw the first one away approach. And this is actually the first place I ever saw it done. I mean, I think I probably first read the Mythical ManMonth back when I was in grad school, which would have been like probably 2003. 2014 is the first time I ever saw anybody actually do this. So Pecky is the company that my husband works for. Their product is a peer-to-peer distributed trust protocol. Like if you imagine a traditional PKI and turn it on its head, to where instead of you have to trust all of these top-down authoritative entities, instead you are the root of your own trust network and you decide who you trust and who you don't. The thing is, when you're writing crypto protocols, you basically can't screw them up. Like if there is a spec bug, congratulations, you just shot your product in the head forever. If there is an implementation bug, well, people will find it and then they will run away from your protocol in terror, wondering what else you messed up. So they took their sweet time putting this together. I mean, conveniently they had runway to do it. Because it took about 2.5 years to get them to the point of the product that they're shipping now. And interestingly enough, they actually ended up keeping about half of the implementation that they did the first time. The system uses Kademlia as a distributed hash table, and they rolled their own implementation of that, and they ended up keeping it because basically after a bunch of auditing, they decided, yeah, we don't think we can really do this part any better. We can write the other parts that talk to it better because we've learned things from building on top of it. But the actual implementation itself is pretty sound. And I mean, eventually it's going to get rewritten in Rust because a real type system would be really nice to have. But the fact that it's a prototype is no excuse to skimp out on modularity. You want to architect your system so that you can throw the first one away. That means designing in a modular way and not ever, 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 ever crossing abstraction boundaries. So what did we actually plan to do? Well, we kind of got dropped into this with, we got dropped into the situation we got dropped into, right? So Emerson got some old colleagues of his interested in this, and they said, okay, well, we've got this amount of money, and we're willing to give you this subset of it, and we'll give you X amount to build a prototype, and if we're happy with what you turn out, then we'll give you twice that much to take it into beta. We're like, okay, seemed good to me. And I mean, this is the second startup I've done, and the first one to actually have a decent amount of funding. So I don't really know a lot about like doing the whole closing a Series A round, stuff like that. But this is you can 1/3, 2/3 your budget if all you have is a large chunk of money up front. But another thing that you have to budget is time. So we got the check in October of 2016, and the way that the climate works, I'm sorry that I can't actually tell you where our pilot project is going to be, because not all of the paperwork is signed yet. But basically, this fall we are going to be actually deploying our system in a region that floods a lot. And the flooding tends to start in late October, early November. Obviously, 1 month was a little too close, to be able to turn anything out for 2016. So we've targeted the 2017 flooding season as our first target. So what does that look like in terms of time? Well, it's 13 months. It doesn't really divide up super neatly, but our funders said, we'd really like to see a prototype by around about the end of February. So we looked at that and said, okay, well, how can we divide this up? And we ended up basically treating the entire prototype phase as part of the planning phase. Brooks suggests use a full 1/3 or more of the time that you have available to you in planning. And I mean, the whole point of doing a prototype is that you are figuring out what it is you're going to need and what it is you're not going to need. Once you've figured that out, then you can use that information in your actual implementation. But sometimes you don't really figure it out. Sometimes you don't really figure out what you'll need and what you won't need until you've actually done it and tried it. So basically, after the prototype, we gave ourselves some time to collect our thoughts and then dive into 3 months of coding. Which we are now 2/3 of the way through. And that leaves 2 months for early stage test and 2 months for full systems test. And I think we're kind of snipping a little on the test side of things, just because that's definitely, those last 4 months are definitely less than half there. That said, they are, well more than half if you look at just what's happening after we started working on the second system at the beginning of March. So, I mean, it's not quite what he described, and we'll see whether things end up exploding later this fall. But so far, we've actually managed to hold to the schedule pretty well. All right, so what are the principles that we're trying to follow as we try to avoid the second system effect? Well, from the very, very beginning in the prototype, continuous build. Like, you don't ever want to get into the situation where somebody is hacking away in their own environment, and then you have to ship their entire box in order for that component to do anything at all. No, you want to figure out what system you are going to build to, and if you have continuous build, continuous integration available to you, then use it. We're using GitLab for source control. That provides continuous integration, so that was really nice. Also, start writing your unit tests and your integration tests from during the prototype phase. You will throw some of them away, but some of those you do actually get to keep, because those tests will test functionality that you have decided to preserve in the second system. But the most important feature of a prototype is that it works in the first place. If we had presented a prototype that did not work, we would not have gotten our second tranche of funding. As you're in the process of doing that, though, it's important to take notes, not just about what worked, but about what didn't work, because you want to be able to remember, when somebody new shows up a couple of months later and says, well, hey, why don't we try X? You want to be able to say, we tried X and it didn't work because A, B, and C. And the other things to keep, I mentioned tests, but you definitely also want to keep your interfaces. I mean, really the most important thing that you are defining when you write your prototype is the interfaces that you want to use going forward. So let's dig into the individual components and see, what they do basically. So this is a screenshot of one of the. This is just the main screen. There's a bunch of workflows that correspond to things like signing up and verification, sending and receiving money, displaying balance and transactions, and oh yes, it also speaks XMPP. That was something that the well, not only that the funders wanted to see, but we figured it's going to be useful, particularly if people have like relatives in other countries. They can communicate with them securely via XMPP with OTR. So that was basically the feature set that we wanted to land for the prototype and pull into the second system. Implementation choice was Java. Then there's all the interesting crypto stuff, which I ended up designing. So cryptocurrency is kind of a misleading term. Crypto ledger would be much, much, much more accurate. And we needed a protocol that represented a ledger, but we didn't need it to be fully distributed because we have a central source of trust in this system. It's the agency that's handing out the money in the first place. If the Red Cross escrows a bunch of money with us, and then issues out basically script versions of this money to people who are in need of aid, they're pretty much the trusted third party. It's their money to begin with. So, I mean, we're keeping this as toy problem simple as we possibly can as well. Like one of the fun features of Git, as it turns out, is that well, it's a linked timestamp chain under the hood. This is this image is from the Wikipedia page on linked timestamp chains, and it basically shows how documents in our use case actually honest to God H-ledger files, just an H-ledger file representing the transaction, gets hashed into the linked timestamp chain that is a Git history. Furthermore, Git lets you sign transactions using OpenPGP, so we basically end up preventing double spending using an OpenPGP PKI and the Java card wallet keeping track of the user's current balance. It's a two-phase transaction protocol. In part, this is because in unreliable network situations, you really never, ever, ever want to end up in the situation where a transaction is just like halfway accomplished and floating out in the ether somewhere. Square actually has a really nice blog post, sorry, now I can't remember if it's Square or Stripe, but one of them at least has a really nice blog post up on two-phase transactions for digital cash. In our case, we kind of get it for free from Git. There are two workflows, and they should be pretty familiar to anybody who's used Git before. Executing a transaction, sending money to someone, is you create create a file representing the transaction in H-ledger format. You add that file to the staging area, you commit it and sign the commit, and you push that to the recipient. You also happen to push it to your own outgoing ledger. We're basically doing double entry accounting over Git. And then consolidating the transaction that you've received is literally just merging it into your own repository of transactions I have received, and then pushing that back up to master. So that's how we end up seeing it. And I'm not going to go into super much detail about how all this works right now, but I'll happily talk about it over a beer later. How did we implement it? Very small shell scripts. This was just a proof of concept. We needed to see that it worked, and Bash was the easiest way to do that. Because we had other stuff going on too, right? We needed a backend API, and we also needed to, be able to keep track of transactions in a sensible way. Well, Odoo worked really well for IDT Labs. That was in fact the backend that they had used for their SMS-based system. So we just went ahead and used that, both for the application backend and for the management backend. We also wrote a higher level API for the app to actually talk to using Flask, and that basically just wraps the low level Odoo API calls. We mocked the two-phase transaction thing because trying to incorporate shell scripts into the full, trying to get shell scripts into the Android app to Web API workflow would have just been way too much of a hassle. We knew that we were going to re-implement them anyway. This was implemented pretty much entirely in Python 3. And then the simulator. So the reason that we're doing this, the reason that we're building a simulation engine is because our customers really are the NGOs, and they have to decide how to allocate funds. But more importantly than that, they also have to figure out, how do I know that I'm allocating money in the right way? And right now, it's really all kind of guesswork. What worked in the past, let's do it again. But you're always fighting the last war that way. So what we decided to do was link together 3 different engines in a mutually reinforcing and communicating way. So we've got an econometric simulator, a traffic simulator, which is actually just a separate component that we grabbed from Stanford, and a network simulator, NS2 in this case. And this allows us to not only test the assumptions of an aid scheme, it also at scale, is this going to end up with terrible income inequality or people starving to death or what? It also lets us test the code at scale, because we can just hook up however many emulated Android instances we want, and put the code through its paces as well. So the prototype implementation language for this was Python, with lots and lots and lots of extra Python fun tacked onto it. And I like Python. My friend Pete Fine likes to say that Python is the second best language for everything, which is actually kind of useful because programs usually need to do more than one thing. This turns out to not always be the best assumption for your second system, but we'll get into that in a little bit. But in order to really pull this off, we had to pre-commit to really throwing the first one away. So Thomas Schelling, the game theorist who died recently, explored pre-commitment a lot in his writing. He points out that cutting off some of your own choices, cutting off some of the options that you have available to you, can actually be a winning move in certain kinds of situations. It sounds crazy, but one counterintuitive result of a lot of Schelling's work is that sometimes being the crazy guy is how you win. And so one way to cut off your options is to pre-commit to building the second system in a different language than the one that you wrote the first system in. Now, for the app, we decided to rewrite it in Kotlin. Kotlin being a JVM language, we could reuse Java code, but we don't want to, and in the end, we didn't. For the backend, what we wrote in Python, we decided to re-implement in Go as microservices. Now, you might say, well, Go isn't a functional language, but Go is a domain-specific language for writing HTTP APIs, and if I have to, I will fight Rob Pike IRL about this. So the ledger protocol, as I said, it was basically originally implemented in Shell, and now it's been implemented in Java as JNI bindings around libgit. The simulator is kind of still in the process. The econometric simulator is essentially being rewritten from the ground up at this point. We started in Python, but it's actually looking like NetLogo is going to be the way to go, because apparently that's what the agent-based simulation field has been using for the history of ever, and it's what all the research is in. And I happen to have one of Alan Kay's former students working for me, so that's working out pretty well. And how about the rest of it? Well, at the moment, it's late May. We're about 2/3 the way into the coding phase, and for the most part, the schedule has not really slipped all that much. Also, thanks to committing to starting our testing early and using continuous integration, we kind of have already started the early test phase of things, so I don't feel as bad about kind of skimping on the time available to that. And you'll notice that, on the calendar from a few slides ago, we had 1 month in the planning phase remaining after the delivery of the prototype, and this turned out to be an amazingly good decision because it gave us time to sit down and document everything that we had figured out. We actually had time to sit down and breathe and talk over how things went and figure out, okay, what do we need to make sure that we remember when we're re-implementing bits of this in May and June. The other thing that we're in the middle of right now is buying hardware. Yeah, because it turns out that if you need to buy like tens of thousands of, or God forbid, millions of NFC smart cards, like there are lead times involved with that. If we want to have those by November, we basically gotta put the 50% down like next week. So that's been exciting. But that said, having more budget from that second tranche of funding has also meant that we've had to do quite a lot of hiring, which it should have occurred to me earlier on to plan time for, but lessons learned. So, re-implementation of the ledger protocol, which we decided to call Flatpak, because really, it's just like you unpack it, you screw a couple of bolts in, and you have an economy. So we hired our 4th developer during the first week of April. We had 1 Android developer and one backend developer during the prototype phase. Then we hired another backend developer. We were still looking for another Android developer, and meanwhile, we picked up another guy. And despite the fact that the first thing I tasked him with was turning the Git command line operations into like a nice JNI library that called libgit2. Oh, and also using the Android NDK for extra tooling hell. Despite his relative lack of experience with either of the languages involved, the total re-implementation only took about a month, which I found really surprising. But what was nice about it was, the fact that the protocol was expressed essentially in the form of Git commands meant that there was a really nice one-to-one mapping and just no crossing of abstractions at all between command line calls and Git library calls. The really awesome one, though, was Kotlin. So my Kotlin guy made this animation just to demonstrate how the conversion went from Java to Kotlin for one file having to do with error reporting. And this is all just like refactoring tools that JetBrains gives you for free. Everything gets a lot shorter and a lot more readable really, really quickly. And I still want to know how they do that really tall cursor thing, because that's just cool. It's almost done. And this is just the IDE doing it for you. The fact that there's such a nice mapping between Java and Kotlin is just really, really pleasant. And the really amazing thing, right? So by the time the Java prototype was done, it was about 30,000 lines of code. Anybody care to take a guess as to how much Kotlin we ended up with? 2,969. Yeah. 10% of the original size. How did this happen? Kotlin is magic. All right. So, Backend stuff. I'm running out of time here, shoot. So I mentioned that we did a lot of documentation during that last planning month. That documentation turned into RAML specifications, and from those you can generate code. What's really nice is if you want to incrementally move over from your old API to your new API, you just take those generated stubs, you pop calls to the Python API calls into the function bodies, and then you just replace them one by one. This is so brain dead simple that it also gave us time to to figure out how we wanted to do load balancing properly, right? So we're deploying on AWS, but yeah, I'm honestly not going to go through this part because it's not that interesting, and I'm running out of time. But basically, we've been able to figure out we've been able to figure out redundancy and failover for both the customer-facing services and the internal-facing services. However, something did have to go wrong, right? Okay. And where that did go wrong was the simulator. So since we're using existing components for the traffic simulator and the network simulator, we decided to focus on the econometric simulator first. The person I hired to do that is somebody I've known for about 25 years now. He actually comes from, career-wise, he actually comes to us from the world of polling. So he has lots of really useful social sciences skills that are crucial for developing a tool like this, but he's really kind of not a CS guy. That said, my developer who used to be Alan Kay's student was feeling kind of underutilized, and so he just jumped in. And so this is so what I want to try to figure out over the rest of this year is how did that actually work? Because he actually sped it up. I'm not really sure what happened there. But what have we learned? Well, most importantly for me at least, I've learned that I have to schedule time for human processes as well as for software processes. Like hiring people takes time, buying stuff takes time. And if you don't make time for them, they're going to take up time that you allocated for something else. It definitely really, really helps to be able to see what depends on what. We used a lot of Trello, we used a lot of Jira, I used a lot of Post-it notes. But being able to see what's blocking what helps you figure out, okay, how can I break things down? How can I assign tasks out so that I'm pipelining things efficiently? Because what Brooks is describing when he talks about sequential tasks and tasks that can be worked on at the same time, it's exactly the same kind of thing as processor pipelining. Something that I wish I had figured out much, much sooner. My first couple of months, I was just sort of agonizing over the fact that I just wasn't really writing code anymore. And this is something that this is a complaint I've heard from a lot of other people who've made the switch from engineering over to management. I never get to write code anymore. And it turns out, if you go and just pair with people, not only do you get to write more code, you get a much more hands-on experience of what people are doing. You see where their pain points are during their workday. You test assumptions that you made about what you expect them to develop. And I think and so far at least, it has sped up the development process for us considerably. So in conclusion, I think that with discipline, the second system effect is actually avoidable. We're not going to know for sure, obviously, until November. But so far, things are working surprisingly well. Are there any questions at this point?
I have a question. On that Java to Kotlin conversion, and of course, Kotlin having been made by the IDE writers,
Absolutely.
It's so easy.
Absolutely, yeah.
You're not really rewriting anything if you're just applying
Absolutely, and I mean, I didn't really go into any of the stuff that he actually rewrote, but for instance, he redid all of the activity stuff to use Magellan, for instance. So there was definitely like some architectural refactoring going on as well. It wasn't just code conversion, but yes.
If Kotlin makes you 10 times more productive than Java, why not adopt Kotlin or some other language like that for the first round?
Because the guy that we had for the first round didn't know Kotlin yet.
Well, I have another comment about that. The fact that it's 10 times easier than you are more productive. Because on the other hand, the IDEs help you write lots of code with few key processes.
Yes.
So like I'm very interested in like how you're gonna document the custom events for me team members. Like because we in our team have a problem with that. People don't read the wiki or like even if you go through the code, loading it with comments is kind of a bad idea. So how do you document that?
That's a good question, and I don't have a great answer to that right now because we're still a very tractable number of people. Like I said, we're only about 9 people, and we've actually kind of made it a point to like keep documentation from sprawling too much, because because you have to organize your documentation too, right? But that's a really good question, and now I'm worried because I am going to have to deal with that problem at some point. So why don't we talk about that over a beer later? How about that? Yes.
You mentioned you've changed languages to sort of be able to re-implement everything.
Yeah, it's a forcing function.
How do you think it will work if it has changed people? So, some people working on this now, we implement this thing maybe in the same language. Do you think that goes possible?
That's certainly, yeah, I mean, that sounds plausible to me. I mean, in our case, our team have some pretty diverse skills. Like, at least one of our backend people could also develop Android code, for instance. But yeah, like it's kind of not their specialty. Yeah, I mean, if I had a team full of people who were all like Rust experts or whatever, yeah, I'd try that. That's a good idea. I saw it. Yes.
Earlier you made a comment about crossing abstraction boundaries. I don't know what that means.
Okay. So think about applications that are made up of libraries. Like, tell you what. In fact, let's talk about real-time operating systems. How about that? Because this is the most recent place I've encountered really, really terrible abstraction boundary problems. So I was working on a project for a 3D printer, actually. I was trying to port some code to from like an 8-bit platform to a 32-bit platform for moving the head, like telling the stepper motor what to do. And what I found was that so usually like in C, right, you expect you expect the implementation to just implement stuff from the header files and not from the header file it corresponds to, and not necessarily like do a bunch of stuff with other with other parts of the system in side effecty ways. And it was basically just impossible to disentangle this code, unfortunately, because like the planner was just straight up using things that were supposed to be the responsibility of the stepper controller, for instance. And so so that's crossing an abstraction boundary. Like when a thing is supposed to be doing its job, but in order to do its job, it has to like reach into the guts of something else and use the guts to do its job rather than just telling that thing, hey, do X. Basically, if you're sending a message to something to do something else, you're lobbing that message over the wall. You're not reaching directly in and am I making any sense at all here?
I think you are. I think I understand the phenomenon you're describing. Yeah, when you have side effects tangling up code.
Right.
So I understand that. Yeah, thank you.
Anybody else? All right. Well, thank you very much for having me.